What if I told you it rains on the sun? NASA just saw something on the sun that could one day shut down Earth's internet. These tiny dots you see on the sun are bigger than entire states on Earth, setting the mystery. For the first time in history, NASA has looked deep into the sun and captured images that shocked scientists. Not because the sun is exploding, not because it is dying, but because it is far more active and complex than we ever imagined. In these images, scientists saw rain falling on the sun, grass like spikes taller than Mount Everest, giant bubbling patterns bigger than Indian states. So the big question is something going wrong with the sun? Or is this normal sun behavior that we never understood before? Let us break it down layer by layer. How did NASA even see this? First of all, this sounds impossible. The sun is extremely bright. It can destroy cameras. And NASA's satellite is very far away. So, how did they do it? NASA used a spacecraft called Solar Dynamics Observatory or SDO. Instead of taking normal photos, SDO looks at the sun using different colors of light, especially ultraviolet light. Why? Because different temperatures glow in different wavelengths. And just like Earth has layers in its atmosphere, the sun also has layers. Layer 1, the corona, where it rains fire. The outermost layer of the sun is called the corona. This layer is insanely hot, millions of degrees. When NASA observed the corona, they saw something unbelievable. Hot plasma was falling back onto the sun like rain. This is called coronal rain. Here is what is happening. The sun is made of charged particles called plasma. The sun has a powerful magnetic field. This magnetic field throws plasma outward as solar flares. But when this plasma cools down, gravity pulls it back. So yes, it literally rains fire on the sun. Why is this important? Because sometimes solar flares don't fall back. They travel toward Earth. And when they do, things go wrong. In 2022, 49 Starlink satellites fell back to Earth. In 2023, a powerful solar storm caused communication blackouts in North America. Over the last few centuries, major solar storms have hit Earth more than 30 times. That's why scientists are watching the sun very closely. Layer 2, the chromosphere, the sun's grass. Next, NASA studied the chromosphere, the middle layer of the sun. Here, scientists saw strange grass-like spikes covering the surface. These spikes appear and disappear every few minutes, are taller than Mount Everest, shoot upward at incredible speed. Why does this happen? Because the sun does not rotate evenly. The middle spins faster than the poles. This twists the magnetic field like a rubber band. When the magnetic field snaps or untangles, shock waves form. These shock waves push plasma upward, creating sharp grass-like structures. Think of it like water jumping upward when loud music vibrates a speaker. Layer 3, the photosphere, giant bubbles and cracks. Now comes the layer we see every day, the photosphere, the visible surface of the sun. At first, NASA thought the cracks they saw were camera errors. But when they zoomed in, they realized these were real structures called solar granules. Each granule is a big as large region on Earth, forms due to hot plasma rising and cool plasma sinking. It's similar to how lava moves inside Earth. Tectonic plates slowly shift. From far away, these bubbles look like cracks. What about the dark spots? You have probably seen dark spot on the sun before. These are called sunspots. They form where the magnetic field is extremely strong. A strong magnetic field slows down particle movement, reduce heat, make the area look dark. So sunspots are not holes. They are cooler regions created by intense magnetism. So is the sun in danger? Here is the surprising truth. Nothing unusual is happening to the sun. All of this is normal sun behavior. The difference is, now we finally have the technology to see it clearly. That's why space agencies are sending so many missions. Why so many solar missions? NASA launched SOHO, Stereo, Parker Solar Probe, Solar Dynamics Observatory. ISRO launched Aditya L1. Why? Because better data means better solar storm prediction, better satellite protection, better safety for Earth's technology. SDO alone sends images every 0.75 seconds with extremely high quality. That is why it changed everything. What's next? Aditya L1 is now watching the sun from a special point in space, perfectly balanced between Earth and the sun. It doesn't fall, it doesn't drift away, and it's helping us understand the sun like never before. So, no, the sun is not breaking, but yes, it is powerful enough to affect our entire planet. And the more we understand it, the safer our future becomes. If you enjoyed this video, hit like, subscribe, and stay curious, because the universe always has more secrets waiting.